Good morning, children. Let's continue discussing the second chapter, that is matter around us pure? So, physical and chemical changes. So, physical and chemical changes. So, here we have written the difference between the physical change and the chemical change. Physical change. So, this change is temporary or reversible. So, this change is temporary or reversible. And the chemical change, these changes are permanent and irreversible. That means we cannot reverse the process, hence it is irreversible. So there is no formation of new product, and in the chemical change there is a formation of new product. A new product is formed here. So there is no energy change in these changes. So there is no energy change in these changes. Energy is either absorbed or evolved in these changes. So example of physical change, melting of ice. Example of burning of wood is the example of chemical change is the burning of wood. So melting of ice. So the melting of ice is a reversible process. That means once we obtain once the ice melts and the water is obtained, again we can get back the ice from that water. When we freeze the water, we will get back the ice. But the same is not in case of chemical change. Once we burn the wood, we get the charcoal, but from the charcoal again we cannot obtain the wood. So hence it is an irreversible process. So there is no formation of new product. So no new product is formed in that case. So but here the formation of new products are there. So that means we obtain the charcoal from the wood, which is a new product. Again, there is no energy change in these changes. So there is no energy change in these changes in case of physical change, but in case of chemical change, so energy is either absorbed or evolved in these changes. So hence we know while burning the wood, energy is evolved in this case. So next, what are the types of pure substances? So types of pure substance. So pure means that there is no mixing in substance. So hence it is pure. A pure substance is made up of same kind of elements. So there are two types of pure substances. What are they? The first one is elements. Lavoisier, so this is the name of a scientist. So Lavoisier defined element as a basic form of matter that cannot be broken down into simpler substances by chemical reaction. So Lavoisier, he defined element as a basic form of matter that cannot be broken down into simpler substances. That means we cannot break that basic element into simpler substances by chemical reactions. The term element is used, and this term, that is the name element, is been used by Robert Boyle, which is the name of another scientist, in 1661. So elements are of three types. There are three types of elements, that is metals, non-metals and metalloids. Examples of some metals are gold, iron, silver, etc. These are the example of some metals. Example of some non-metals are carbon, oxygen, etc. And examples of some metalloids are boron, silicon, etc. Now properties of metals. As we have already learned about these properties in the lower class also, that they are lustrous. That means they are shiny. So metals are shiny in nature. So they conduct heat and electricity, so they are very good conductor of heat and electricity. They are ductile. That means we can draw them into wires. If we pull the metals, so we can draw them into wires. They are malleable in nature. That means it can be hammered into thin sheets. These metals we can hammer and make them into thin sheets. They are sonorous. That means make ringing sound. So when you hit them, it makes a ringing sound. So hence they are sonorous. So example, iron, copper, gold, etc. All these are metals and these have got these properties. That means they are shiny in nature, they are good conductor of heat and electricity, they are ductile, that means they can be drawn into wires, we can make wires from them. They are malleable in nature, that means we can hammer them and make them into sheets. And they are sonorous. That means when we hit them, they make a ringing sound. Now properties of non-metals. So they display variety of colors. Variety of colors are actually found in case of non-metals. They are non-lustrous, non-sonorous and non-malleable. So they are not lustrous, they are not shiny, they are not sonorous, that means they do not make any ringing sound while we hit them, and they are not malleable, that means we cannot beat them or hammer them into thin sheets. So they are poor conductors of heat and electricity. So they are also poor conductors of heat and electricity, unlike metals which are very good conductors of heat and electricity. So example, nitrogen, coal, oxygen, etc. All these are examples of non-metals. Now properties of metalloids, they have intermediate properties between metals and non-metals. So their properties are between metals and non-metals. So some of the examples of metalloids are given: silicon, boron, germanium, etc. So these are the examples of some of the metalloids. So the next is compound. So first we have already learned about the elements. So now the second one is compounds. It is composed of two or more elements in a fixed ratio. A compound is formed by two or more elements in a fixed ratio. So substances cannot be separated by physical methods. So these substances cannot be separated by physical methods. Compounds show different properties from the elements. So the compounds, it shows, that means compound, it is a mixture of different substances, and the properties of this compound is different from that of the substances actually which make the compound. For example, hydrogen, oxygen. So hydrogen and oxygen, they combine together to form water, that is H2O. That means in water we find hydrogen and oxygen, but the properties of water is different from that of hydrogen and oxygen. So hence it is written that compounds show different properties. So this is a compound, but they show different properties than that of the elements. But we must be careful that compounds is different from a mixture. It is not a mixture, it is different from a mixture. So let's understand the difference between compound and mixture from this table. As you can see in the picture, that is mixtures, elements or compounds just mix together to form a mixture and no new compound is formed. But in case of compound, elements react to form new compounds, they react to form new compounds. But in case of mixture, they just mix and no new substance is formed in this case. The second point is a mixture has a variable composition. A mixture can have different types of composition, but the composition of each new substance is always fixed. But in case of compound, as we know, the ratio is already fixed. Which substance will combine in what ratio, it is already fixed. The point 3, that is a mixture shows the properties of the constituent substances. A mixture, it shows the properties of the constituent substances. If different types of substances are mixed together, then the mixture will obviously exhibit the property of those constituent substances. But in case of compounds, the new substances has totally different properties. If we have already learned with the example that the properties of water is different from that of hydrogen and oxygen. Point number 4, the constituents can be separated fairly easily by physical methods. The constituents of the mixtures, it can be separated easily by physical methods. But here in case of compounds, the constituents can be separated only by chemical or electrochemical reactions. We have to use chemical or electrochemical reactions to separate the constituents. So therefore, overall we can say that a matter is basically classified in two types, as it is given in a picture, that matter is classified in pure substance and mixture. Again, the pure substance is divided into two parts, that is elements and compounds. So elements that cannot be broken down into simpler substances, for example copper, oxygen, iron, hydrogen, mercury, etc. And compounds, they have a fixed composition and can be broken down into elements by chemical or electrochemical reactions. You must remember, we cannot separate them physically, we can separate them only by chemical or electrochemical reactions. For example, water, methane, sugar, salt, etc. all these are compounds. And mixture, so it consists of homogeneous and heterogeneous mixture. As the beginning of the chapter we have learned about homogeneous and heterogeneous mixtures. So homogeneous, it is of uniform composition, and heterogeneous, it is of non-uniform compositions. So homogeneous mixture, for example, sugar in water, salt in water, sulfur in carbon disulfide, water in alcohol, etc. And a heterogeneous mixture, for example, sand and salt, and sugar and salt, water in oil, etc. When we mix sand and water, salt and water, salt in sugar, and oil in water, all these are heterogeneous mixtures because the mixture is non-uniform in composition. So with this we have finished this chapter. So that's all for today.